and it focuses on the, let's say, interplay between MEC and an NFV environment, that is the system architecture, how the ETSI ISG MEC views it, as compared, of course, to the current architecture of NFV, and what are the main key issues that are faced in view of this study. So just to give let's say a teaser or a brief example, since the report will be out in a few weeks' time, so unfortunately I think it's not yet uploaded at the open area of the ETSI portal. We refer to the MEC architecture, how is it, let's say, mapped or related to the NFV architecture, and then we come up with discussing a number of key issues and possible solutions that can be provided, for example, when it comes to different error interfaces between different blocks of the two architectures. So this is an ongoing study. This is an informative work, it's not normative. So the anticipation is that in what comes next, we will hopefully come up with some normative work, of course, in strong collaboration with the ISG NFV.
Okay, I have to try. So since it's informative and it's coming in 2 weeks, give us something. what are the key issues, or what has been something that has let's say taken most of your efforts in this looking at what are the challenges of NFV and MEC their work.
So in a nutshell, although the conclusions have not been shaped yet, so
okay.
This is ongoing work. And,
so yes, maybe say it's your conclusions, at least from your work, and not the conclusions of the group, but that's okay.
So for example, a MEC, an ME application is going to be treated as a VNF, as a virtualized network function.
Okay.
So given that, we try to map the MEC architecture within the NFV environment. And there are certain interfaces that need to be specified with the aim of optimally or smoothly reach a conclusion.
Okay, Simone. So you have been also looking at this. What is Vodafone doing in this area? Are you just contributing to the standardization, or doing already some first lab trials with vendors and things like that, or what have you been doing on this regard? I mean, you mentioned
we are certainly contributing to the ETSI MEC and also MEC NFV. People there trying to put our hands on this topic. But we also have our NFV strategy. Many of you might know our internal project called NFV transformation of our internal network, internal core network. So one of our goals is to kind of align our NFV strategy with MEC strategy. So try to reuse as much as possible from the NFV efforts that we are putting into this project for future MEC deployment and application. We also are working with vendors and try to investigate some proof of concept on how this could be done in our network.
Okay, so I want to break here for a second, because you two, seem very aligned on what you're doing. You both, you don't mention it, but there's an assumption that mobile edge computing is under the NFV umbrella, right? You say the architecture is going to be mapping to the NFV because you treat the mobile edge computing applications as BNFs. And then I want to ask, and maybe Guy, it's your turn, but maybe anyone can contribute to that answer. I want to ask, is that the only option? So we only have, are we only just going to have mobile edge computing as a virtualized thing? So there's no bare metal mobile edge computing platforms, everything is going to be really under the NFV umbrella?
I think when we say that certainly VNF is likely to be the predominant model from our perspective initially, and it may not be simply virtual machines, it may be containers, but there's nothing from our perspective as a vendor that precludes the possibility of using bare metal in any service chain environment. You know, from our perspective, we're focusing on how this all fits together as a set of virtual network functions. And yes, the MEC applications are virtual functions, but in reality, in many cases, the MEC server itself is a virtual function. And my perspective really is that in that case, you kind of construct service chains through the MEC server, but also looped around the MEC server. So all you're doing is constructing service chains in different ways. It's just...
Okay, but before the service chain, let's leave that for later.
Okay.
So if we, I mean, I think we have to all move back and see, okay, what are we trying to achieve with mobile edge computing? And then, if I look at it, at least my impression, and I would like the Vodafone impression, not mine, what are you trying to achieve with mobile edge computing? And I will give you two possible answers. I know operators, you can add any answer, and even the audience can, if they have a different answer, please contribute to this discussion. So I know operators that tell me, we want to achieve the low latency. We're not going to have low latency, or the low latency that we want for augmented reality, for industrial applications and things like that, without the mobile edge computing. That's the first answer. But I have another answer, which is a bit more alternative, and I have seen some presentations of Vodafone, I think it was Vodafone Germany in this case, that went a bit in that direction. That is, we want to actually monetize a lot of hardware that we have near the base stations and we no longer need because of the C-RAN and things like that. And now we have racks there that we can actually monetize and sell cloud space on those racks, which is very near the radio and it's very low latency, so it has high value for certain applications. You can add any possible answer or choose between these two, or maybe find something in the middle. What do you say?
The first answer is right. We want to achieve low latency. The second answer is could also be right because we have a lot of compute available in different locations in our networks, and then every market has its own strategy regarding that. So we don't know yet the business model. If that's another topic for another workshop, another panel probably, how to really monetize these zones. If we do services, if we let others do services.
Yeah, you could sell it. We could sell it completely to Amazon Web Services.
But one goal is try to manage this infrastructure, manage these hundreds, thousands, I don't know how many nodes, in a unified way as much as possible. I mean, I know that
that's more a requirement, right, than actually an objective. So you will have to manage it in a unified way because you want to reduce your management cost and all that, and the operational cost of managing such a complex infrastructure. But the objective has to be something else, right? That's like a consequence, right?
Yeah, the objective are always towards the customer, like give the customer the right quality of experience that they need, low latency, and requirements that we need LEC in place. If you have the right business case, the right motivation, you can also think of some other deployments like, I don't know, not NFV or what you said before, like bare metal, private, completely private on-premises LEC nodes. This could also be possible if we have a right motivation to do that.
Okay, but right now you don't see that motivation here. You are more under the umbrella of NFV.
Yes,
okay.
we are trying to follow the standards and trying to put everyone, vendors and other operators at the same table.
Yeah, so assuming we are under the umbrella of NFV, so I guess you all agree because no one raised his hand or wanted to discuss fiercely about this topic. So we say mobile edge computing is going to be under the umbrella of NFV. Then comes the topic of the orchestration and the management of those mobile edge computing NFV points of presence, infrastructure, and all that. Guy, you want to talk in that direction?
I was just going to say that really one of the reasons I think why NFV has been the focus so far is that it provides you with the facility. If you're going to move everything towards the edge in order to achieve low latency, then as a consequence of that, your scope of management becomes much smaller, and your scope of traffic becomes much smaller.
Yes.
And therefore, the business case for putting a single hardware-based, what amounts to a bare metal server for a single task is much harder to meet. It becomes much more effective to use the tools of virtualization, of cloudification, to use a horrible term, to actually make optimal use of big resources and spread them across multiple applications.
There's an implicit assumption there that the resources are big. It could be a very small hardware, just purpose. Yeah.
But the direction that we're seeing most operators move in is the concept of having a big, relatively substantial hardware platform deployed at a sort of mid-level point within the RAN, so that it's not too far to the edge that it becomes insanely expensive. It's not too far to the core in that you lose all your latency benefits. And as a consequence of that, you kind of need relatively substantial hardware, but you need to deploy it in a way that makes it possible to deploy many applications across that. And that I think is why there's very much more focus on NFV as an approach with which you can achieve that. And then, as Simone pointed out,
Sure. I mean, what you're saying is basically we're going to put the MEC server at the BBU, the same place where the BBUs are going to be, and of course it's a virtualized infrastructure. And then the number of MEC servers and of infrastructure that you're going to have virtualized is not so large as it could be if you do it completely at the edge. Do you agree with that approach? Do you see also that in that direction? I mean, you're a radio expert, you can tell us something.
Okay, so maybe to bring up an example, I can refer to a centralized run versus a distributed run deployment, where in the centralized case, almost all functionalities apart from the low PHY, low RF ones are centralized at the node, whereas the remote radio heads are just responsible for some tasks of filtering, of AD conversion, and so on. And on the other side of the spectrum, we have distributed run, where or partially centralized run or fractionally centralized run, where the split point is at the higher layer in the protocol stack. So what do we gain and what do we lose in this case? In the fully centralized case, we have gains in terms of coordination. So for example, coordinated multi-point processing can be
I suspect the audience doesn't know about that, but don't worry. Let's move on.
So it's a means of better coordinating the various radio resources in order to serve a bunch of users. But on the other hand, there is a price to pay, and what is the price to pay in terms of centralization is the signaling overhead between the distributed unit, let's say at the site. We have a millimeter wave access point or a G node B. So in this case, in the fully centralized option, they're either wireless or wired by means of Ethernet or C3. Front haul network is going to be really congested. So what is a good answer in terms of having a win-win situation? I would say that we can harvest the benefits of a SYNRAM deployment by exploiting SDN on top as an orchestrator and NFV.
Look, I can follow that, but for reasons that, and I know there's someone in the audience who can also follow that topic, but I suspect most of the people cannot follow that because it's like too much into the CRAN, front haul, CPRI, all this stuff. Most of the people probably here. Who knows what CPRI is? Can you raise your hand? Oh, there are plenty of people that know. I'm surprised. It's not important. Forget it. let's move to new splits and to what's coming with 5G and not with the old technology. But okay. Let's go back to the topic of, I want to go back to an anchor point that I said when you were saying, yeah, when we move the mobile edge computing server a bit to the edge, the scale reduces and the complexity reduces of the software that we're going to deploy there. It's going to have to manage less amount of subscribers and traffic and all that, right? So it makes things simpler or easier.
Lower load.
Yes, but we are moving that complexity, and I think Simone wanted to talk about the orchestration complexity, because I think what we are rising is the complexity on the management and orchestration of all those nodes, right? And depending how
nothing comes for free.
Nothing comes for free. You're just moving the complexity from one area to the next, and I'm very bored of talking about NFV orchestration. I've been talking about NFV orchestration for 3 years now. I'm really bored about this topic, but it's a topic which is still not solved. So how do you see it, Simone? Are you bored as well of the topic of orchestration, like myself, or not?
I'm not bored because it's my job. But I would like to see, for example, NFV progress on that. Let's see NFV progress on that, taking into account the new MEC recommendation or best practices that you are publishing. But I mean, generally, this is a hard problem, or how to manage these multiple distributed nodes, and how to manage the infrastructure at the NFV level, and how to manage any application on this infrastructure, how to have this nested orchestration, because you need to manage both the nodes, platform, MEC platform itself, and the any application on top. And if you add, for example, mobility issue, if you add users moving from an edge to another edge, how you orchestrate this any application to follow the user maybe, or to instantiate multiple times and just switch on when the user moves.
This is a huge issue from NEC.
And you expect a solution from the standardization?
I expect some collaboration on that,
I mean, so far,
collaborative agreement.
What I would expect from the standards organisations is the means for applications to be given the information they require to be able to transfer state. Because the alternatives for migrating a single UE from one MEC server to another are really unpalatable. You know, the idea of instantiating a new VM for every UE that you can move, that's intolerable.
Okay.
Even a new container for every UE. You know, when you're talking about tens of thousands of UEs attached to a single MEC server, that doesn't work. You have to move the state so that the application has to be able to do that. But it's only the MEC platform that has the information that this subscriber is about to jump ship.
Okay. Do we have any experts in core network in the room? Someone that is very knowledgeable with the EPC procedures and things like that? Can you raise your hand? We have only one. Okay. They are just looking to do like a handover with MME and serving gateway relocation, but for mobile edge computing applications, which is something that was done already. Yeah.
Instantiate an app, right? The app could exist there, already there.
Absolutely.
An app just because faster.
The app can be. One would assume if you offer a service across a particular region, you would instantiate the application in every location where it needs to be. The challenge is to
move the context.
To take the context,
yeah.
exactly.
So it's a handover with context relocation that I was referring to.
It's application level. Right?
Yes.
So there's a certain amount of baseline information that perhaps all or most applications would want to see transferred to the other side. And then there's any amount of application-specific knowledge that's required to do it.
Yep.
So how does the application get keyed that it needs to introduce this handover? What is the sequencing of that handover? So make before break before make.
Yeah.
Certain applications might say, I don't care, just show up on the other instance and we'll take care of it. It's A-okay.
Reattachment.
Yeah. Yeah, I mean, but it's not at the same level of procedure. We're up in application space now. So I
Yeah,
think
sure.
that's always been a challenge.
Yeah, but the interesting thing is that they expect, I don't expect it at all, I mean, I'm not so optimistic as they are, that the standardization bodies are going to provide a solution for that, for something which is application level. Either they provide a solution and it will never go anywhere, or they won't provide a solution and something proprietary will happen, right?
I'm not sure that the standards bodies will create the solution. What I'm saying is they need to provide the
A reference.
information northbound through some kind of API that the applications can use. Because today there is this absolute...
But the problem is, and I have seen that also in the last MEC Congress in Munich, the discussion was going there around, we need ETSI to provide APIs that the applications are never used. I have never seen, and maybe I'm not too old, but I have never seen a telco standardization body designing an API that applications have used. So this is, do we have an example of something like OMA APIs that have been used by any applications that are not directly by telco providers, so like third parties? And we are always talking that the applications that we want to have in the mobile edge computing servers are not the ones of the telco providers, but from third parties. These people are never going to use the APIs of ETSI, 3GPP, OMA, or
Maybe
anything like that.
something like AWS Greengrass becomes the API.
Yes, that could be. That's I agree. Maybe if we have a microphone for the people in the back, don't shout. Just we get that microphone in 1 second. So.
Thank you. And I think that's really what I wanted to flag up. Are we at risk of over-engineering this by demanding mobility when AWS has given us a clear example of a localized solution serving a specific use and working?
No,
And that seems to work.
The challenge is still in effect to give AWS Greengrass the user context information that says this user is going to show up in this specific MEC server because the MEC server knows about location. The MEC server knows that this UE, which happens to be tied to a car moving at 100 kilometers an hour down the A1 motorway, is going, it's seen it move through this set of ENOVs. It knows that the next one on the A1 is this one, and that is associated with a different MEC server. And it has to come from the that information has to come up from the network. And if AWS is going to be the de facto, AWS Greengrass is going to become the de facto API, then it needs that information.
Contributing a little bit more to the mobility discussion from a standardization point of view, in the ETSI portal open area, one can, free of charge of course, take a look at the MEC 18 report. That is the one that refers to end-to-end mobility. So it's again an informative report. And on top of that, we should be, in my view, from a standardization standpoint, always prudent when it comes to how mobility, or I think in 3GPP is called session and service continuity or service migration treated. What are the triggers for service migration? Because the different SDOs, the different standardization bodies should be on the same page.
And which use case actually requires it? So we're talking about automotive here, so, but yeah, please.
Exactly right. It's application level continuity, and not all applications will need it, but I could foresee lots of them that do. And the source of this information is not the MEC platform itself. The source is the mobility network. It's the EBC that knows where and when the thing's going to be migrated. So we're potentially introducing even more complexity by necking that back down through the MEC platform. But we do need a solution. I think we do need to support a class of applications that support this kind of service continuity. And there could be some primitives that MEC promotes in terms of making the base context information available, perhaps even primitives that suggest how that can be augmented with application data for transport to the new site.
If you want to say something about SDN, there are no further questions about the topic, because I wanted that we talk about orchestration and SDN, but I think we are on the time. Yeah, it's exactly 4:30, so we have finished the panel. If there's one last thing, how, like very super briefly, how does SDN play a role also? Because we haven't talked at all.
The only thing I would say, SDN is the common orchestration approach for delivering virtualized networks. And
Sure.
all virtualized networks are therefore is to connect virtualized functions and connect them between each other and into the physical world. And that's all I see.
Are you also seeing SDN as a key thing for mobile edge computing, or?
Yes.
Okay.
There's a key thing both within the MEC node to connect and change
Different applications.
different application and between nodes. So, and if we can reuse as much as possible again.
Okay. And has SDN been a topic in your standardization work, or is like a hidden topic because often NFV shadows a bit SDN?
At least in the work item that I follow, it's MEC within an NFV environment. So SDN has not been for the
Okay.
for now looked at. But as a very final message, I would for sure agree both with Guy and with Simone that softwareization would act definitely constructively in terms of reconfigurability of the network, having really diverse use cases with conflicting QoS requirements.
Well, thank you very much to you three and to the audience for your questions and contributions. So, thank you.
Thank you.